Good morning, students. Today we're going to start our transformations piece here. As I promised, I'm going to have you focus on taking notes correctly. So you obviously all have in front of you the actual notes, the screenshots here. I did add in this glider reflection over here that you can add onto your sheet itself. So what I want to focus on is you listening to what I say besides what's written on the screen. Just like in class, poor note takers only write down what is on the screen. Good note takers are always listening to what the teacher says and is adding those pieces to it. The teacher's always adding on to here what's here, such as giving common errors or little hints here and there what to look for. It'll make things easier. We don't always write it down. So that's why you always have to be listening to what the teacher says. So I want you focusing on anytime I'm adding something that's not written down here as a hint to write that down. You can even say pause the video right now so I can write that down. Because obviously this is a teaching lesson for taking notes. So obviously at home, if I didn't give you these notes at the time, you would just print out these sheets themselves and then focus on listening to what I'm saying to add on to these notes. Okay, this is what you have to do if you want to be successful in college as well. Same thing in college. Teachers can write down everything that's important. They just write down key ideas, and you have to figure out the rest from what they're saying and what to add to your notes. All right, so let's go ahead. Transformations. That's the general main topic of what we have here, and we're going to talk about five, not today overall, but five transformations. You see the translation, rotation, dilation, reflection, and over here glide reflection. Okay, for these five, the translation, rotation, reflection, and glide reflection are called rigid motions. Okay, and it says that right here, four types of rigid motions: translation, rotation, reflection, and glide reflection. Now, the park and Engage New York focus on these first three. I'm not saying they might not throw this in here. Uh, I haven't seen it written, I don't think, on the park or the DCAS. They focus on these three. A glide reflection, if you look over here, is a combination of a reflection first and then a translation second. So I think that's why they don't focus on that as itself as a word, because you already have the two pieces of a reflection and translation in here. Okay, so on the DCAS, they'll say which of these combinations of isometries or rigid motions, as you see another name for rigid motion is isometry. Okay, so to be familiar with both, they use both these on the DCAS. They will focus on rigid motion more, but you might see on one or two problems isometry in there. You need to understand they're the same thing, and they're only talking about these three. And if you can think of glide reflection also, it is also a rigid motion. So what is rigid motion? All rigid motions are congruent. We'll come back up to these definitions here in just a second. All rigid motions are congruent. Notice the shapes are the same size and shape. Okay, congruence. We've talked about congruence figures already. So, what are the key things that rigid motions preserve? Rigid motions preserve angle measure and distance. These are the two things that the DCAS will focus on. In fact, that could be a question on the DCAS right there. What are preserved by rigid motions or isometries? Angle measure and distance are the two words they're looking for. And that's what, and the idea of congruency, okay, in Engage New York, in a DCAS, they focus on congruency as one of these four rigid motions. Mainly, like I said, they focus on these three right here. Okay, but glide reflection also is because it's a combination of a reflection and a translation. Okay, uh, so what they're saying is if you can move okay, so the original picture, you notice there's two pictures in each of these. The original picture, vocab-wise, is called the pre-image. So in this case, the blue are the pre-images. Okay, the image is called the final figure. Okay, now it's easy to remember which one is which because pre means before. Obviously, that's going to be the first one. Pre-image is the original picture. Image is the second one. As it says here, the image often have primes with them. Look like an apostrophe is a prime. You don't see them on here because I don't have letters here, but you see it right here. B prime, A prime, C prime. So since these do not have primes on them, these are the pre-image. The pre-image does not have a prime on it. The images do. So notice these have one hash mark or primes. They're actual called primes. This one has two primes on each letter. That means this one took place first and this one took place second. Okay, and we see the same thing over here with the glide reflection. You can see it went here first. Here's our pre-image because there's no primes on it. Image, first image, and second image or final image. Okay, with the double primes on them. Okay, uh, so um, going back to congruency on the DCAS, when they talk about congruent figures, they'll say if I can move one figure, a pre-image, to another figure by any combination of these, then the figures are congruent. So the idea of isometries or rigid motions is tied to the definition of congruence. So you need to understand that they love to talk about congruence with rigid motions. If I can move any original picture pre-image to an image, okay, blue is in this case pre-image, red image, as you see the arrow, okay, then, and it's the same shape, then that's the definition of a congruent figure. So I can get from the pre-image to the image by translation or rotation, reflection or glide reflection, then the figures are congruent. And they will actually, on the DCAS, ask a question about that and want you to use that in your proof of showing why the pre-image and the image are congruent. You need to state because I can go from the pre-image to the image by whatever combination of translations, rotations, or reflection, or glide reflection to get from the pre-image to the image. That's what they want to hear. They want to hear you use that word rigid motion and then name which rigid motions you use to get from the pre-image to the image. I'm just telling you that's guaranteed on the DCAS, along with talking about preserving angle, measure, and distance. Okay. The fifth transformation um, that we'll talk about, not today, but the following class, is a dilation. Dilation is almost all the time get either bigger or smaller. Okay. And so they are not congruent unless it's a 1-to-1 ratio, then they would be congruent. It's the only time a dilation would be congruent. If it's a 1-to-1 ratio. So if this is the pre-image, this is the image from blue to red, this could be half of that. Okay, obviously not congruent. Okay, so the vast majority, 99.5% of the time or more, dilations are not congruent, and so they're not an isometry or a rigid motion. Or rigid motion or isometry, they must be congruent. Okay, so now let's talk about these definitions here, and then we're going to focus today on translations and reflections. Next class, rotations and possibly dilations, depending on if I can fit that in there. Try to do both together. If not, one and then the other. All right, so translation. So right here in middle school, you might have learned it as a slide. Okay, I've had a lot of prior students say, yeah, we call that slide middle school. Okay, that's not the technical name. The technical name is translation. How does translation occur from here to here? It's two reflections over parallel lines. Now, when we do these problems for your homework, today, your assignment today, you're not going to have to know that to do the problems, but you need to know this definition because I'm going to throw it on a quiz in our test, and they may ask you that. I've seen it asked that on the DCAS. It used to be called the park. Okay, so you got to know the definition. Rotation, right here, rotates it. Okay, is two reflections over intersecting lines. So both these are two reflections, but one's over parallel lines. If I just slide it, or if I rotate it, it's over intersecting lines. Now, down here, this was the center of rotation. You might not be able to see it because I have the black overlap, but there was the center of rotation right there. I connected two corresponding points, this corresponding pre-image point to its corresponding image point. If I was doing this by hand, okay, I could connect any two corresponding points. So I just chose that one and that corresponding point to it. Connect it to the center of rotation, the point they gave me. Now I would take a protractor and measure that angle, and that's how many degrees it was rotated. Okay, using a protractor. We are not going to be focused on doing that. Now we might do it right before the decast. Just a quick reminder, but we're going to be focused on doing everything in the coordinate plane. All these in the coordinate plane. Okay, but that's how you would do it if you were doing it by hand. If you had two, pictures, connect two corresponding points to the center rotation, and use your protractor and measure it. Okay. Uh, reflection is a singular reflection. All reflections have to be at 90 degrees to the line and the same distance away. So for example, if I look over here, B to B prime. If I connected the B and B prime, it'd form a 90-degree angle perpendicular to that line, and that distance from here to here would be the exact same distance here to here. Okay. Here, if I looked at these two, connect those two right there, it'd be 90 degrees or perpendicular to that line, and the exact same distance from there to there, the same distance from there to there. That's how all reflections have to take place. Okay. You don't go at any other angle than 90 degrees to the line of reflection. In glider reflection, as it tells you, is a single reflection, like this one, plus a translation. So they do a single reflection and then they translate it. Remember, translation is two reflections. So I have 1 plus 2 to move it there for a total of 3. So a reflection and a glider reflection, one reflection, glider reflection, 3 reflections. Translation and rotation, 2 reflections. That's key to remember. Okay. When we look at the next page here, and then we'll come back and look at this one to explain how we can tell which one of these 4 it was just by looking at what's called its orientation. So let's go to the next page for orientation, and we'll come back there. We already talked about the pre-image and image. I put it on. I originally had this as the first page, and so I added stuff from the first page. I went back and changed the first page to the other one. So that's why there's some repeat right here. Okay, you see the definition again for translation. Okay, we see that already. I had this on the prior page as well. Okay, not on your notes. On your notes, it's only right here. But I added to the prior page right before doing this video. All right, so orientation now. Orientation is either clockwise or counterclockwise. That's the only 2 answers for orientation. Okay, so I'm put CC for counterclockwise. Okay, now what's key about that? Going back to here. So when we talk about orientation, you pick. So I picked this as A, B, and C. Okay, this little point on here is A, that little point B, and that little point C. That wasn't originally there. I had named points so I can look at its orientation. Okay, and then I reflected over this one line. Obviously, this reflects to here, this reflects to here, this reflects to here, and you see the primes in here. So you know this was the pre-image. This is the image. It's got the primes. The pre-image does not. If I look at this orientation is clockwise. This orientation right down here is counterclockwise. So every time you do an odd number of reflections, either 1 or 3, so 1 is just called a reflection, 3 we just looked at the last page called a glider reflection, it's going to switch orientation. So that's why it says switches right here. The orientation switches. So it's clockwise and then went to counterclockwise. It doesn't always have to start clockwise. It could have started, I could put the A, B, and C here, and then it would have been counterclockwise for the pre-image, but then the image would have become clockwise. Okay. So if there's an even number of reflections, and remember, we're talking about translation and a rotation, both of these have 2 reflections, so there's an even number of reflections, the orientation will stay the same. So the value in that, and knowing that, and checking that first to compare pre-image and image, as it says right here, the value checking the orientation of the pre-image to the image so that you can eliminate 2 of the 4 possible transformations, thus enabling you to more easily figure out which transformation map the pre-image to the image. Now the reason I say 2 of the 4, because we're really talking about, I say possible transformation, I could have said possible rigid motions instead, or isometries. That's really what we're focused on, these isometries right here. We're going to say that 2 of these 4 isometries. Okay, we're not talking about dilation at all. That's a whole separate game. Okay, but the rigid motions or isometries is these four we're talking about. So we're eliminating two of the four. If it's two reflections, the orientation is going to be the same, and that possibility is either translation or rotation. If the orientation switches, the only possibilities it could be is a reflection or a glide reflection. So you've eliminated two of the four just by checking its orientation. Okay, so now let's go back and look at this right here. So here's an example why you cannot trust Google. When I typed in, I typed in Google. In Google, I typed in glide reflection picture. It gave me this picture. So on your worksheet, on your notes that you have here, right above this, it says glide reflection. And I was going over this with the lab class yesterday, and we end up seeing, I'm checking this out, I'm like, wait a second, this isn't a glide reflection. Even though you got a reflection here, okay, you got two just like you have down here. This is not a glide reflection. And so that's why I went ahead and explained to the lab class how you can tell. And we talked about the orientation then. So if I look right here, if I call this A, B, and C, I reflect this across, I get these ones, and I reflect what I see down here, and I have these ones right here. Well, if I look right here, this orientation, ABC, is counterclockwise. If I then look at the final picture, the final image, remember that's the pre-image, that's the image, pre-image, no primes. The images have primes, and since it's got double prime, this is the final image. Okay, if I look at this orientation, so remember this one, counterclockwise, and this one, counterclockwise. Well, if they're both the same orientation, remember we just got done saying it's same orientation, the only two possibilities are translation and rotation. So that's why I knew when I had written glide reflection, because that's what Google told me and gave me this picture, that it was wrong. So here's an example where we can't trust Google. So erase or cross out glide reflection above it here. I went and then found a glide reflection, went and checked it myself and saw it. And so you can add this picture to your notes now. So this is a true glide reflection. Okay. So now the question is, remember we got it down to here to here. We got it down to same orientation. It's either rotation or translation. Okay. That means how can I tell which is which? It's very easy to tell. On a translation, you notice the picture looks exactly the same. It's not rotated. All it is slid. Okay. Now, notice this right angle, how this is faced right here. This is not facing the same way right here. It'd be flat here and coming up here and down here like this. It'd be like this. It's not even this. This is flipped as well. It'd have to look exactly like this, just shifted down here if it was a translation. Since that is not what has happened, then it's automatically a rotation. So this is a rotation, okay? And but this reflected over the y-axis, got this one, then it took this and reflected over the x-axis. When you reflect over the y-axis and the x-axis, and it doesn't matter which order, I could reflect over the x-axis first and then the y-axis, I would still get the same picture. That is a rotation of 180 degrees. We'll be talking about that next class. So remember today we're talking about translations and reflections. Next class we'll talk about rotations. So we'll see that. I'm just telling you that right now. So you can go ahead and write rotation 180 degrees. Okay, for this here, because that's what that actually is. It's not a glide reflection like Google had told me it was. Okay, that's why you can't always trust everything. You gotta know what you're talking about. All right, so now we're going to go ahead and look at our translations and our reflections for today. So here I picked problems just like those off your assignment. It's changed the numbers. That's what your assignment problems are going to look like. So it says A, and we're just going to do point as individual points. Okay, right here. It could be an entire triangle. It could be a quadrilateral that you're doing these translations for. We're going to practice that in class next. Okay, so plot the point A is -5, right there. This right here, as you see right here, is called a translation rule, and you're gonna have to write these on the DCAS. You'll see it one written like this, and it's gonna ask you to multiple choice, for example, pick the final answer of what this translation is from a figure like a triangle or quadrilateral. So what this says is to plug in -5 for the x, so you're just gonna add 2 to it. So negative 5 plus 2 is negative 3. The easy way to think of that is it just shifts it. Remember, x direction is left or right. It just, I'm adding 2, so that's to the right. So I'm going 2 to the right, and then minus 3 from the y means 3 down. So 2 right, 3 down. So if they ask what this means, you would write 2 right, 3 down. That would be your answer. Okay, and there's my a prime, because a was my original. Remember, prime is the image. Okay, that's simple. If it's a triangle, you just do it with all 3 points. For all 3 points, you just go right 2, down 3. Take the other pre-image point, right 2, down 3. That's all you're doing, and then reconnect them. Okay, another way to write a translation is capital T, and then this is your x coordinate and your y coordinate, like this right here, the x and the y. So this says left 1, up 3. So I plot my original, 3, negative 3. They didn't give me a name for the point, so I just call it A. You can choose anything. And I'm going to go left 1, up 3. Left 1, up 3. And there's my image point, A prime, as I call the original image A. All right, last example for this one. Write the translation rule, and I show you the format for it, just like we see right here. And they give you the 2 points, the pre-image point and the image point. That's all they give you. They don't give it from the drawing. The easiest way to do that is to subtract, like it says here, image minus pre-image. So 8 minus 2 is plus 10. And 3 minus 2 is plus 1. Okay? You cannot, common error students make is they forget to put this and they only want to focus on this piece of it. When you write the translation rule, you have to write the whole thing. It automatically starts with x comma y, arrow, parentheses, x, and then plus or minus, depending on what you get when you subtract there, comma y, either plus or minus, whatever you get, subtract there. Now, if you don't want to think of subtracting, the other way to think of this is going from here. I'm starting at negative 2, and I have to end up at positive 8. How much do I have to add to that? I have to add 10. Here I'm starting at 2, and I'm going up to 3. How much do I have to add to that? 1. That's the other way if you want to think about doing it, if you don't want to just do image minus pre-image. All right, that's how easy translations are in the coordinate plane. And that's what you're going to be doing. All right, next we have reflections. Okay, as we already talked about on the first page, reflections are at 90 degrees to the line of reflection and the same distance away on both sides. Okay, now we're going to talk about here these 5 major reflection lines. Okay, the x-axis, y-axis, the origin, the line y equals x, which is this line, the most famous line in math, 45-degree angles. Remember, this is 0, 90, 180, 270, and back up to 360. So halfway between 0 and 90, 45 degrees. So the slope of 1, remember that's the slope of 1, up 1, right 1. Slope of 1 from algebra 1 is a 45-degree angle. Now you know your degrees. All slope of 1s are a 45-degree angle. That's just a side note. Just a slope of negative 1 would be at a negative 45 degrees. Remember, if I go 0, I can go back negative 90, negative 180, negative 270, negative 360. So a slope of negative 1 is a negative 45-degree angle. So just remember that when you think about the degrees of slope of 1 and negative 1. When you, especially, you know, for algebra 2, for example. We don't have to know it for geometry. They aren't going to ask that question. But anyway, since we're talking about degrees and geometry, you should be, you know, affiliate. Slope of 1 is 45 degrees. Slope of negative 1 is negative 45 degrees. Notice I don't have that written down here, so that would be something you would add to your notes. Okay, so reflections now. Here's an example. Plot A is 2, 3, reflect over the x-axis. It's got to be 90 degrees. Simplest way is just to count down. 1, 2, 3. So I go 1, 2, 3. And there's your image point. And again, it can be with the entire triangle. You just pick the 3 corners of your triangle, do the same thing. Okay, and then reconnect them. And here we have A and then A prime. So you can see that was the original, that was the image, pre-image to the image. Now, you can, to me, it's just easiest to count like that. But if you want to memorize these rules along here, okay, the first 2 should be easiest counting wise. I'd recommend possibly memorizing these last 3 rules right here. It's just going to save you time. Okay, a lot of time if you memorize the last these 3 or these first 2 are very simple just to count. Okay, so if we go to reflect over the y-axis, if I start here, reflect over the y-axis, well, it's just a horizontal. That's going to be 90 degrees. I just count the distance. 1, 2, 3. So I go back 1, 2, 3. Okay, 90 degrees to it, and same distance away, A to A prime. Very simple. Okay. The origin now. Um, so when I went over this with the lab class, it wasn't working out. And then I figured out why. There's an error here. Again, this came from a book. You got to figure the books are right. That's why you can't always trust everything. You got to know what you're talking about and have confidence in what you're talking about. So if I reflect through the origin, when I connect my pre-image point to my image point, it must go through the origin. So notice they plotted -3, -2 right there. So when I was doing this, I was telling the kids, okay, it's got to go through the origin. I'm looking like this, and it's not going through the origin. I'm like, what the heck is wrong? So then I had to see, like, yeah, 3, 2 is supposed to become -3, -2. And I was trying to figure out what's wrong. And then I went ahead and checked, and they hadn't plotted the point right. -3, -2 is right over here. So I put that in there. They put the point right there. That's plotted incorrectly. So now, if you go ahead and connect the actual true points, you see it goes right through the origin. Okay, so when you reflect over the origin, it will always go through it. So you usually will have guaranteed one on the park or DCAS that will be that'll go right through the origin like that. If you look at a pre-image and the image point right away and connect them, you see they'll go right through the origin. Therefore, you know it's going to be a rotation 180 degrees. When it reflects to the origin, like that, it's a same as a rotation 180 degrees. We'll talk about rotations next class, like I said. So rotation 180 is guaranteed to be on the DCAS. I'm just telling you, and so it'll be on your assignment here, test. You'll see it on your unit at the end of the module 1 test. It'll be on there because again, you're going to see on the DCAS as well. Okay, guaranteed. Simple rule to remember for that is just AB. As you see, they're using AB. It's the same as XY. So it just becomes -x, -y. She just put negatives on both the x and the y. So the 3, 2 becomes -3, -2 right there. Okay, that's a simple rule for rotation of 180 degrees or reflection over the origin. Okay, next one is y equals x. Y equals x, most famous line in math. What you see here, xy becomes yx. They just switch the x and y coordinates. So here's an example. A 1, 3. I just blew it up because I wanted to put the line in here. You can't really see the 1, 3, so I wrote it up here. 1, 3. When I reflect 1, 3 over this line, it comes right here, and that is 3, 1. And you see just the x and y's get switched. Okay. Now, when you reflect over the line y equals -x, it's the hardest one for most people to memorize. And remember, not only if I look at this becomes xy becomes yx. Well, same thing here. The x and y switch, but now you add the two opposites on top of that as well. Now, like I said, it's easiest just to memorize these, but here it be if you want to come up with it on your own. You pick up, you draw the line y equals -x right there. You pick a point real close to it. I picked that point. I reflected over that line. Remember, it's going to be at 90 degrees, same distance that of the land right there. What was that point? -1, 2. And where did it land on? -2, 1. Well, I can see that the x and the y switched, and I took the opposite sign. 2 became -2, and -1 became +1. And so I could come up with that rule myself if I ever forgot it by picking a point just like that right next to the line y equals x and reflect it across and compare the pre-image point to the image point and come up with that rule. But it's simplest just to memorize that. And of course, you can just use that when you're plotting them on your assignment today. Okay, so let's look at 3 examples there, and then you can get to your homework, your assignment here. Little r, as I say right here, means reflection. So these are reflections. Okay, this is a short way of writing this. Now in the DCAS, they're going to write out the whole word reflection. They're going to give it to you in this format right here. Okay, this is the simplified format. Okay, so they haven't write it all out. DCAS, it writes it all out in words for you. All right, so it says reflect the point -4, -3. So there's -4, -3 over the line x equals -2. So you need to remember that x equals a number are all vertical lines, and then it's going to go through -2 at the x on the x-axis. There's -2 on the x-axis, vertical line. So draw that again. 90 degrees is just be now horizontal. So I just count to it. 1, 2 there, 1, 2 there. And what is that point? 0, -3. I call that A because again, they didn't give you a name to call it, so you can pick any letter you want. A, then the image point is A prime. All right, here we have two reflections. So that was a single reflection. Now we're doing two reflections. Now if they're over parallel lines, that'd be a translation. But notice I've got the two lines drawn here and they intersect. So we're actually rotating the segment here. Now, as I pointed out here, this little O, it's like in the middle. It's not up high, it's right in the middle. That means following. This is called function notation. Okay, you'll do more of that in Algebra 2 and Pre-Calc. Okay, but you can write it in with isometries as well. Again, it's just a shortened way of writing it. Like I told you on the DCAS, they'll write all this out in words. They'll say reflection over line y equals x after doing a reflection over line x equals 2. They'll have it all written out in words like that. Okay, so on the DCAS, you won't have to remembering that. But just remember, it's in a function notation. This means following. So that means you're always doing the right one first. I'm going to do that reflection first, that one second, every time. I circle that and said do first again to remind you. First one is on the right, then you do the left one. Okay, so plot the points. 3, 4, right here, and 1, 2. There's my AB. It says reflect over line x equals -2. There's the x equals -2 again. I count 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Reconnect them. Okay, so that would be my A prime and B prime. I just didn't put that there. I put the actual coordinates because the next one is reflection over line y equals x. That one right here, remember? And I wrote down that rule again. It's up here. Okay, but I went ahead and wrote it down here. This is what I recommend you do every time on your assignment when you're doing one of these, either y equals x, y equals -x, or I don't have the origin one on there. I just have y equals x and -x to choose them. But write it down each time, so that's going to help you to memorize it for the test or quiz. Okay. And remember that. So the rule is all you do is switch the x and y coordinates. That's it. So this -7, 4 becomes 4, -7. That -5, 2 becomes 2, -5. And now go ahead and plot them both and connect them. And there's your final image. So there's my pre-image, there's my A and B prime, and then this would be A double prime and B double prime. Okay, right here. And so this is rotated. Okay, because it's through two intersecting reflections over two intersecting lines. That's a rotation. So we rotated this. Okay, and finally, last one. Same idea as what we did here. It's just another example. Okay, x-axis first. So plot the two. Here's my A and my B. Plot the two. I reflect over the x-axis. So I count up 3, 3, 2, 2. So the blue you can see is A prime and B prime. Reconnect them. Then this is over the line y equals -x. So again, write down the rule for it, even though you have it up here in your notes. Write it down again to help you memorize it. So remember, that means switch the x and the y and put the opposite signs on both. You need to think about telling yourself that verbally as you're saying it. Don't just write it down, verbally say that. That's how you help memorize it. Okay, so I just take those points, the A prime, B prime points, and apply that rule to it. So -3, 3 becomes -3, 3 also when I apply it. So that's why A double prime and A prime are on the same point. And that's because the line y equals -x goes right like that through it, and that is on the line itself. That's why it reflects right back onto itself. And lastly, 3, -2, I apply this, switch the x and the y, and take the opposites, becomes 2, -3. And so I plot 2, -3, and connect them, and that's the purple ones here. So you see double prime, double prime. Okay, and there's my final answer right there. All right, and that is it for this lesson. So now you can go ahead and work on your assignment. Like I said, next class we'll do rotations and ordinations.